Good afternoon. I trust you can hear me, even though I'm having a few technical issues on my side. Thank you to the entire team for the Center for Affordable Housing Finance in Africa for inviting me back this year. I very much appreciate it. So I believe there was an introduction, but my name is Fatou Dieye. I work for SCAT Consulting Rwanda, which is a project here, which is a company that is implementing a project for the Swiss Agency for Development and Cooperation. And so I will present some of the findings and research that we're doing within the framework of that project today. So just to give you some context, I shared this last time, but it's a little bit of a refresher for everybody. Just so you know about urbanization in the Great Lakes region and what is happening. So where we work and where this project is situated is actually in one of the world's fastest urbanizing areas. Rwanda, Burundi, and the Eastern Congo, DRC is where we are based. And Rwanda was actually the fastest urbanizing area in the world between 1990 and 2018. And now Burundi is projected to urbanize the fastest in the coming decades. So you can see on the map on your left that really it is one of the great hot zones of a big boom on the African continent. And if you look at the expansion pattern that goes along with this urbanization in the four main cities, so Kigali, Bukavu, Goma, and Bujumbura, you can see that they're growing at a rapid rate. However, most of that growth is actually informal. So the expansion patterns are, as you can see on the slide, the top of these cities, most of them have about 30% of formal construction. The rest is actually informal. And by the time we reach 2050, there will be 20 million new urban dwellers across these four cities. So really there is a pressing need, of course, if you have more dwellers, there's a pressing need for quality, affordable housing. Currently, for many reasons, which I will discuss, the way that the housing market, it's mostly informal. And so people build village houses, but they do it in an urban context, using mud bricks, rukarakara is the way it's called here in Rwanda, and the predominant material really is mud and wood, most especially wood when it comes to Bukavu. Now, what it means is that there's a settlement pattern and a densification that happens in an unplanned way. We call that settlement infarction, which means it's not able to build upwards, so it just sprawls. And so you see incredibly congested areas. This aerial photograph has a photo of Bukavu, and this represents about 10 days of urban expansion. So 3,000 houses that are built every 10 days across these four cities. And so this, as you can see, is a major, major challenge. And of course, there are always disasters, and especially now that the climate has changed, rainstorms are a lot more frequent, so there are storm damages to the houses, landslides, incredibly dangerous. In places like Bukavu, where they build primarily of wood, there are many frequent low-intensity disasters, several fires per year that wipe out hundreds of houses within minutes, and then people rebuild in the same areas. And this is what the current reconstruction reality is. So it means that people don't even, in many cases, choose to, it's preferable to build preparing for the next disaster, not investing too much, because you know inevitably you have to replace the housing stock. And so what are the challenges that come with that? Is that we now have these vertically growing or desire for vertical growth in the African cities, especially here in Rwanda, where the government has gone to enormous lengths to publish and make proper building codes. There are upgrading codes, there are land use plans, there's a new master plan for Kigali, all of these new regulations with the idea to be able to get the country that will hopefully soon be a middle income country, to be able to have housing and building stock that is fit for this type of activity. And of course, housing and the median income are, of course, tightly related, because housing should be a major growth factor and employment factor within a developing country. The reality, unfortunately, even though there are those ambitious master plans, the reality of urban housing is actually quite different. Currently, the formal housing supply is only at the top of the income pyramid. Everything at the bottom is either substandard housing or informal housing, and there are hundreds being built every day in the region using the materials that are locally available. The problem is that then for urban buildings, there's a lack of skills. And so contractors are not necessarily fit, and they struggle with building tall story buildings. And so this is an example of something that you see in Bukavu. And then, of course, that creates extreme vulnerability in these places that are already sensitive, and for these populations that are already searching and needing proper housing solutions. On top of it, this growth in the cities is requiring more building materials. There are few local strong value chains here in the region, and so people mostly go outside searching for cement. And cement comes from some here in the country, in Rwanda, but mostly from our neighbors in Tanzania, in Kenya, Uganda. So all of that capital is actually going to the neighbors rather than staying here and actually nourishing and feeding what should be a strong construction industry, considering that the demand is so high. In the region, in 2015 alone, there was $100 million that were sent outside of the country, which is equivalent to about 50,000 workers' income that could have been here if there had been other solutions for being able to build. And right now there are few. And so what happens, of course, is that then we fall back on the traditional building material production that has been popular here, for 50, 60 years, which is bricks, fired bricks. And those bricks require firewood, which, although in Rwanda is completely illegal to use firewood for firing bricks, it is because the need for building materials is so incredibly high. So you end up in a situation where it's already an area where deforestation is a problem, and once the need for these bricks gets so high, it is incredibly high right now post-COVID. The impact on the environment is felt on many levels. So at deforestation, but also when we talk about emissions and CO2 emissions. So the objective of our project, which is called ProEco, Promoting Off-Farm Employment Through the Production of Climate Responsive Building Materials, that objective of that project is to reduce the urbanization's climate impact. And it's also at the same time to tap into the unused employment potential. And you can do this, of course, by making safe urban housing affordable and available at mass scale. This project has been around since 2012. It is a project of the Swiss Agency for Development and Cooperation. They have a long-standing collaboration with the Rwandan government and the Burundian government in the Great Lakes region. They've been here since the 60s. And so the commitment to being able to help build larger cities that can really help the community thrive is something that the Swiss Agency for Development and Cooperation has been committed to for quite some time. And so if you actually start to look at the housing curve and to really understand what this potential is, this is the objective of the project, and you can see really that the houses, the need for housing is immense. The part of the market share of formal and informal and substandard housing is quite large. And so really the idea is to come and replace and find solutions that can actually provide affordable housing to people and switch from informal to formal solutions. And we imagine that you could have at least 40% market share by producing locally sourced building materials, most specifically brick. Now, what does that mean in terms of a real challenge by 2050, just so we understand the volumes that we're talking about and the type of solutions that we need to plan for? What it means is that you would need about 5,000 urban dwellings, proper formal urban dwellings by 2050. It would also mean that we're currently, by not doing this, we're losing, we could potentially lose 300,000 employments that are gone to the cement industry, which again is mostly outside of the country. So what can we do to figure out how to keep those employments here in the country? And if we look at what it does to our environment, 100 million trees are unnecessarily cut by producing these substandard brick products that I showed earlier. And so the impact of that is about 40 million tons of CO2 that are unnecessarily emitted. If we could find a proper local solution, you could begin then to reduce the emissions, create employment, and then of course generate the dwellings that you actually need to meet the demand. And so our mandate in all this is to facilitate a green change in the urban housing supply. So to look at solutions that are environment friendly, that also allow you to go to mass scale. How do we do that? We have an approach that's not just finding design solutions actually, but acting as industry facilitators, so surgeons for the value chain. So if you think of a typical construction value chain, which might be, from your designer, your architect, your engineer, your client, and your builder, and eventually a tenant or someone who buys the home. Really, if you're going to rethink how housing is supplied in this area, you need to look at the whole value chain. So here we have about 32 different actors, from the people who are making the building materials, sawdust, quarrying, molding, firing of bricks, the brokers who sell them, the site managers who are on the site, and the bankers and the media who are responsible for doing the promotion and the financing of housing solutions. And so our job is not to replace any of these actors, but to capacitate them, to allow them to perform at the level that they need to be able to deliver all of the housing that is required. Basically, we can then break the housing chain into different groups. So at one area, we come up with solutions that are aimed at figuring out better concept design and engineering, also supporting housing finance. The project also looks at construction solutions, inside client business, trade and quality certification, and building material production. So again, we're everywhere along the value chain. Everywhere you see an orange dot, that's where we play the intermediary to try and create win-win solutions between different partners along the value chain, all with the idea to be able to build this so that it is strong and that it could allow the number of houses that we need to be created across the region. And so what does that look like? So from the concept design and engineering perspective, that can be new dweller-driven settlement upgrading methods that draw from some of the legal documents that are already in place, especially here in Rwanda, affordable and green urban housing typologies, pre-engineered construction design solutions that can be available for people to be able to take those documents and actually be able to build with them. We also offer easy to build storied walls and slab solutions that are, again, available for the public, trainings for contractors and masons, quality management and inspection methods, all with the aim of course, reinforcing the strength of the construction sector. Similarly, now the project offers, low carbon technologies for load-bearing brick walls, machine designs for products that require less cement, and the coaching of brick makers and other building material suppliers along the value chain. With that in mind, we then, to give you an example of some of the tools, so there are owner-driven settlement upgrading tools. We have on the left, as you can see, some cartoons, some typical plans of how you can begin to transform entire neighborhoods, and all these documents are available for local communities, for authorities, for investors, bankers, etc. We offer modular and customizable building systems, so that really allow us to create affordable housing that can be duplicated and customized according to people's needs, according to their budget, and of course, according to their preferences. Easy to build walling systems, as I mentioned, pre-engineered designs, and then of course, tools that allow local authorities, civil engineers, building inspectors, everybody to be able to use and learn how to use these technologies and apply them again at a larger scale. We have calculators and cost climate performance calculators that allow you to see the different types of construction system and what would be the environmental benefits of each one. Housing supply chain calculators to be able, again, to calculate what do you need in terms of how many engineers, how many architects, how many laboratories to test bricks, all of that to be able to build up the supply chain to deliver the housing. So given all of that, the project has been working on building that up for the past 7 years. And what has been really exciting for us is that we've had the opportunity to do a proof of concept, to test it out, to see how it is working, what the reception is, and to fine tune all those tools so that they can be, when the project closes, they can be transferred to the private sector. And so we did this at 3 scales, and those are what I will describe to you today. The first scale is the scale of the house. So what we did was to start looking again at this value chain to zoom in on really the construction aspect. And how could we come up with something, given the limited purchasing power, how could we come up with a module or a type of housing that was cost effective, that was customizable, and easy to build and replicable? And so in 2017, we introduced what we called the 8 million franc house, which at the time was a little less than $10,000. And so that includes everything, including taxes, contractor profit, everything except for the land. And the idea was to show that you could build something with entirely local materials and really be able to achieve the cost savings that we need in order for the population to be able to access these houses. So with the usual construction cost, we're about at $350 minimum per square meter here. With the way that we've chosen to build with what we call a cost optimized design, and I will show you some of the features afterwards, we reduce the amount of cement mortar that is required by using a different technology, and that allows us really to shift to a design that is much more locally focused. So with a common design, you have about $200, which is actually material inputs from outside. With this optimum design, you have about $80 of the cost per square meter that goes to the construction of the house. Now, in addition to the local materials, the other thing is the working class bond. And so what we did was really look at what you can actually do with a typical brick. And we decided to reinvent or give a new life to something called the Rolock bond, which is a cavity wall technology. And this cavity wall is not something that we've invented. It's been around since the Industrial Revolution, but it's actually something that allows you to reinforce the wall so the wall becomes load bearing. So no longer do you have column and beam structures. You actually have a wall that carries the loads from the roof all the way down to the foundation. And that means that everything inside can then become entirely flexible. And so it can be in that way incremental, that people can begin to put in walls and partitions as long as they have the finances to do so. And this technology has actually been adopted and promoted very heavily in Kathmandu after the last earthquake, because that reinforcing of the wall allows it to be performed quite well during seismic events. And so even this little first cube that we built, you can see all the reinforcement that's actually inside the building. You can't see it, you don't see columns, you don't see beams. What you see are these, what we call strengtheners, both horizontal and vertical, that allow the building to stay together and protect it in the case of an earthquake. So in addition to that, using those technologies, you see that we're able to drive the walling cost down from $18 per square meter roughly to about $12 per square meter by, again, reducing the amount of cement mortar, coming with a better environmentally friendly improved brick product, which also creates more employment. So 2.5 person days per square meter as opposed to 1.5 person days, and also consumes much less energy because it is fired with bio waste and not the firewood that is technically banned. And again, with this load-bearing wall structure, you find yourself with the ability to have a freedom inside, which means you can have apartments, you can turn it into a duplex. It can actually, two duplexes can come together. There's a whole level of flexibility that's in here. So what we're promoting is not necessarily architecture, but a construction system that allows you to achieve the cost and the price point that is necessary. Flexible interiors, totally easy to maintain. You can see that you can have a studio 1 year, as I said, then an apartment, then a duplex, then a city villa by beginning to join different units together. And that flexibility, we actually then turned it into a full-scale model. So we started with the small 1 unit and then built an 8-in-1 unit in an informal settlement as a demonstration. And it is fully occupied, renters, tenants, as well as landowners live in this unit, and it's able to meet all the requirements of the master plan, as well as be there at the cost that was required. Since we built that building in 2018, it has been duplicated across the region. In Rwanda, it's already been copied with this technology, different versions of it. There are about 1,500 copycat dwellings since 2018. The last time I saw you last year, it was about half that amount. So they continue to propagate all over the region, which is really quite exciting. The issue is, of course, that now the building material demand becomes higher. So we've managed to generate jobs in construction and jobs in producing bricks, but the industry, of course, needs more. If we go back to the figures that I mentioned at the beginning, 5 million houses are going to be needed by 2050. There really needs to be an engine to supply, a manufacturing engine to supply all of these bricks for all of these houses. And that's really is also part and parcel of our job. The good news also, besides the fact that the house has been replicated many times, is that the city of Kigali, which has just adopted or launched its new master plan 2050, has designated a special zone, and the equivalent to about 32 square kilometers, that are a zone for our type of, for this model type of housing. So the Swiss Development and Cooperation's model houses now are able to be built in 32 square kilometers around the city, and soon we hope that it'll also be in the secondary cities. Again, this creates an immense pressure for the building material producers, as well as an immense opportunity, because they should get organized now, and that's where we're supporting them to be able to deliver the all of the bricks required for this. So given that we now have this massive interest, this massive demand, and a shortage, we then started to look at a slightly bigger scale, again, as we wait for the full industry transformation to occur. And so that scale was a scale of the plot. We know that people are still building, and they still require bricks to build those buildings. And so what we did was, going back to our value chain, was to look again, what win-win situations can we create between different actors? And so bringing together the construction, the builder, the developer builder, and the building material producers, we were able to facilitate a new mini value chain linkage that is able to supply bricks immediately to people who are building. I will show you an example of that. So now that we have this master plan, which you see up on your left, that has R2, that is our model building, the first model building, that zone is now designated in the master plan. We also know that Kigali, in the small map that you see there, has an immense clay potentiality. So how can we marry this idea that the clay and the raw material required for proper material for modern bricks is available in the city? How do we marry that with the demand for bricks, and think about it at the plot scale in a way that it can address those people who are looking to build today? So we came up with what we call a plot-based solution for developers. And what we did was we relied really on some of the design and the work that we're doing to design machinery, proper machinery that allows for good working conditions and allows to produce good products. And what you're seeing here is a team that we call a mobile team that is producing modern bricks using a mobile machine. This machine is about $1,500. And with this machine, you could build about 20, you can make enough bricks for 20 dwelling units per year. And so that becomes really interesting for this small scale developer that has a plot of 5 hectares, 10 hectares, and is looking to build 20, 30, 40 houses maximum over a span of maybe 2 to 3 years. If they were to get several of these machines with several of these teams that we've trained, they could actually work directly on a site. And so here's a sketch of how this could potentially work. And this is an existing project, actually. On this site, there is an area for clay delivery. We have set up temporary structures, temporary hangars, where production of clay, modern bricks can be done using this machinery that is all mobile. So mobile extruders, as well as a mobile crusher. And number 3, you will see that there's something that we're calling a septic kiln. And what that means is that since this is a residential project that will require a septic tank anyway, we help the developer build the septic tank, so in the same budget line, but we actually use it temporarily as a kiln. And so you're able to fire all these bricks that are produced on site in this kiln, and you store them in number 4, and then you build directly on your site. And so there are now five of these sites running across the region. And it's actually quite interesting for a developer because they can control the quality of their product. If they're not happy with the product, they can tell the mobile team to start it again. At the same time, the mobile team is able to create, or these small producers who cannot invest in a big factory are able to create mobile production units and sell their services to a developer. So again, this is a win-win situation where we're able to get green products directly on the site. We don't do transportation or have to pay for additional transportation costs, and the buildings are built using the technologies that are promoted by the project. If you just an image on the left, that is the septic kiln, which immediately, once we remove the hanger that's above it and the chimney, you can immediately connect this to the buildings and be able to use it. So it's for the project. So it's already sized according to the needs of the project. And what we found is it is incredibly facile to use. All the pieces, once the mobile team is done producing, the hangers, everything is, the machines, the chimney, everything is collapsible, and they can go then and produce on another site. And then The developer can then, of course, sell or rent the units and develop another plot if they wish to. But really, it means that then people are busy. Bricks are being produced, houses are being built, despite the fact that the industry itself at large is still in this process of transformation with larger kiln factories being built. But this can really, this matchmaking really allows us to be able to unblock some of the affordable housing bottlenecks that currently exist. Just to let you know a difference about price. So self-production of a brick, it's about around on site $77 per thousand bricks. Now, if you were to buy these on the market today, they're minimum USD $110 per thousand brick. And that, of course, is without transport. So really, there is a savings for the developer by putting this temporary solution on site. The city has approved it in terms of being environment friendly, that the chimney is there, but there isn't smoke billowing out of it. As you can see, it's on the left-hand side of the picture, and they're able, most importantly, to get the units that they need onto the market immediately without delay. And of course, there is the aspect of quality control. This is actually what the project looks like today. They finished the first block of 6, and there will be 2 more blocks, so 20 housing units. And then after that, the mobile team will disappear and head to another site, and this will be hooked up to the quote unquote septic kiln. So the third scale that we're looking at now is the scale of the neighborhood. How to be able to think about green transformation of neighborhoods using some of these technologies, creating employment, and at the same time, responding to the needs of the community. Our current site where we're working is a pilot zone that's actually not too far from the city center. So it really is a densely packed area. Most people work in the service industry. It is a prime spot, a lot of singles who are renting on during the week and head home maybe to the district on the weekend. And the idea is to try and pilot a rehousing project so that all of those people can actually remain in the neighborhood. It's not to transform the neighborhood and then chase them away with higher prices and accommodation that isn't suitable for their needs. In order to do that, you know, we have to bridge this gap that exists between what the reality is and actually the vision that you see on the left of the master plan, and also, you know, those who make the decisions and the authorities of how to actually be able to achieve this master plan vision. And we think that there are ways to do it, and that's actually what we're working on now. And so the idea, if you look at the area that we're working on now, it's about, you know, some 450 households, about 1,000 dwellers are living there. And so the idea is, how do you take all those people, understand what their needs and their preferences are, put in a new building, new buildings, plural, that they can afford, and really think about what a new neighborhood pattern should look like that allows them to have outdoor space, indoor space, and all of the, and be able to build in such a way that we don't have the drainage and stormwater issues that we currently have in this type of neighborhood. The first thing we did was we set up a partnership with the University of Rwanda and the School of Architecture, and the students, we did an exhaustive, excuse me, mapping and trying to understand what the existing typologies were at the site. Again, extremely important to match the needs of the people that are currently on the site with the solutions that are being proposed, with the technologies, how they can be adapted to best meet their needs. And so from this survey, of course, one of the types of information that we can glean, of course, is to assign an approximate value to what they currently have. So what is the value of their current structures, and how do we make sure in any type of upgrading project that those things are taken into account as we move forward and build other solutions. But more importantly, going on the site, you're able to understand the relationship between tenants and owners. And the idea that there are multiple families living on many of these plots, and how do you not disturb those structures, especially because in many cases you'll find that the owner may not even live on the plot. For example, here in plot number 201, all of these units that are on the site are actually rental units. And so you go from a logic that we typically hear of about housing of rent to own to an idea of own to rent. So everybody that owns a plot part of the reason that they own it and they build these structures is so that they can get income for it. So it's really important to reserve and to respect that structure when thinking about how to redesign these neighborhoods in partnership with the community. And so by doing that mapping, we also did a socioeconomic survey. We were, of course, able to see, what is currently existing, how many owners, how many tenants, how many 3 bedrooms, how many 2 bedrooms, et cetera, and to think about what the mix should be when you want to be able to plan a new settlement. But in addition, by doing the really architectural mapping and the socioeconomic survey, we dug deeper. What are the businesses? Tenants versus property owners. What are the toilet and kitchen facilities? What are the priorities for people? Do they prefer big windows over an outdoor toilet? How are they managing the stormwater on their plot? How are their utilities managed? What is the issue with garbage collection? And all that now needs to figure in and come and lay over the technological solutions that we have. And so we've been working with UN Habitat as well to be able to run this process. And this then allows us to go back, once we have all those ideas about and answers about the preferences and focus groups responding to certain prompts, we can come back to our catalog, which is one of the tools that the project offers, is this catalog of pre-engineered designs, and use that as a base for people to be able to figure out, what is it that I actually want? Do I need to maintain my tenant income? Do I really need a 3-bedroom, 4-bedroom because I have let's say 2 families actually living together? What are the options to begin to discuss? And so this catalog of solutions, actually, we organized it like t-shirts, so small, medium, large, extra large, and XXL. And everything is in there to form the basis to be able to have a discussion with the community. And again, that discussion is extremely technical because it is based on a construction system, but it also is based on all of the aspects that make up their habits and their preferences when it comes to housing. And so the block typologies that we're looking at now to be able to replace the density that is there are a lot more dense. So we're calling them micro real estates. And the idea, of course, is that then these are not individually owned. We're now talking about communal ownership. And that's also something that is quite rich and quite complex and needs to be planned out properly. And when you plan micro real estates, you need to plan for the building, but you also need to plan for the management afterwards. And so should there be a small community fund to be able to do the upkeep afterwards? Should there be vouchers to support with now formal plumbing and utility bills, which they might not have had previously? How do they come together to share space in these new buildings while still maintaining the preferences that they had at the beginning? The other tool that we're able to use is this calculation tool that we have for upgrading costs, because the idea, of course, is if you're going to do this at the scale of the city, and that's what our job is to figure out how to upscale these types of solutions. The idea, of course, is to figure out how this can pay for itself. And so the price of the land, the size of the houses, what people currently have versus what they will need in the future, the building footprints, all the different types of units that are available, all that information now can be used to think about what a new settlement pattern could look like. So we would go from the pattern that you see on the left, which is very dispersed, to what you see on the right. And this idea is that if you build now a storied urban building that meets the requirements of the master plan, so we're talking 2 to 3 stories, not more, using the affordable technologies that we are working with, you should be able to sell other portions of your land. And that land that's being sold, consolidated and sold, should finance the construction that is happening. And so the construction cost minus the value of the sellable land should in theory allow for the affordable upgrading costs required for people to be able to self-finance an improvement in their homes. And this is, using just a quick sketch of what this could look like, where along the edges you would have more commercial buildings that are zoned commercially. They're on commercially zoned land that can be sold off, and then the middle buildings are used to house the existing population. And in that way, again, this is a model that could be self-financed and multiplied at a larger scale. So we are currently working with the city of Kigali to do the first test of this exercise. We picked the strip precisely that goes up the hill, even though it is quite, will pose some challenges in terms of construction, but it also poses incredible opportunities to be able to show how this cross-financing can work, and all the legal tools that are required to be able to make this happen and happen later on at scale. And so if we just start to do, quick calculations and based on the current value of the land in this area, which again is high value because it's so centrally located, what the construction costs that we're able to get, the $200 to $250 per square meter, the number of bricks that creates, that it would require, the number of jobs that it creates, et cetera, et cetera. We're able to come with a net investment required of $1 million, which is exactly the budget of the city in this first exercise. And then you see what the average investment is per plot, looking at the interest rates and other projects and opportunities that are currently available in Rwanda. We will be able to pilot this as a first model for a self-financed upgrading of a neighborhood here in Rwanda, using all of the green materials in a way that builds the value chain. We will of course be supporting the city of Kigali to set up the production facilities that can feed these types of projects directly. So there would be again this growth of the production capacity and the supply capacity to meet finally the demand capacity that is quite high. And so just about how you would, just to end, an idea of how you would begin to think about how to allocate the units and how to get people to actually join in on the process, because it should be a participatory process and people should feel that their needs and desires are, of course, respected. And so putting them together based on looking at what they currently have, what their new needs are, and then of course having them be organized possibly in these cooperatives. And so there would be two levels of cooperatives. One level at the cooperative at the level of a building, which will allow you to meet the condominium law, and a cooperative at the level of the strip that is the self-financeable module that you need of about 50 plots minimum to be able to make the math work so that you could cross-finance the development. And if we look again at the scale of this entire region, this entire neighborhood, which is again right below the city center, the pilot neighborhood would require about 6 cooperatives that we would create in order to be able to have this happen. Those 200 cooperatives would be needed for the entire area and for the entire informal zone of Kimisagara. So both sides of the hill, for those of you that know the area, would be about 700 cooperatives. They would each be working and supported by the tools that are offered by the project to be able to access the green materials that are needed, and also the model plans and all of the discussion guides that would allow them to facilitate their transformation. And this, of course, at the scale of the city. Thank you very much.
Fatu, I don't know if you can hear me. I suspect not, but there's lots of comments for you to look at. Colleagues, please find Fatu. I think that was such an inspiring presentation, and I could have listened on, and certainly intend to connect with Fatu again afterwards. We need to rush. We have to go to another room to maintain our agenda. So thank you very much for participating in this session. And if you need to find Fatu and you can't, you know where to find me and I'll help you. All the best. Bye-bye.